This is video 14 Algebra, and we're going to be talking about solving mathematical sentences or mathematical equations today. So I'd like you to take a look at the board. Here on the board we have x plus 2 equals 4. Now you and I both know that x substitutes for a number. So this is some number plus 2 equals 4. And we all know, don't we, that 2 plus 2 equals 4. So if you're sitting there very smug saying, I know the answer to this already, please relax, because what I'd like to show you is I would like to show you how to do this using a balanced scale technique. Now for those of you who are new to algebra, I have to tell you that one of the main reasons we study algebra is for problem-solving techniques. It's great exercise for your brain. So get ready. We know that x equals 2, and that's what I am here to find out. What does x equal? And we know x equals 2. But using a balanced scale technique, we're going to find out that, oh, that doesn't look like a balanced scale at all. We are going to find out that one side of the equation equals the other. So here is the mathematical sentence or the equation. And we know that x plus 2 equals 4. Whatever you do to this side of the equation is what you're going to do to this side of the equation. You have to keep them balanced. So, you want to see how we're going to do it? The main objective is to make x stand all by itself on this side of the equal sign. And how do we let x stand all by itself on this side of the equal sign? Well, what we do is we're going to get rid of the plus 2. Now, if you have plus $2 in your pocket, how do you get rid of it? You spend it. If you have plus $2 in the bank and you want to get rid of it, you spend it. So we are going to spend our plus 2 by adding a negative 2. Plus 2 and minus 2 give me 0. And whatever I do to this side of the equation, I need to do to this side of the equation. So here I have a plus 2 and a minus 2. And that's going to give me 0. 4 minus 2 is 2. I bring my x over, and x equals 2. And we knew that already, didn't we? Okay, let's try it again. Let's see if you can do it. We want to use this balanced scale technique. Okay, the balanced scale technique. Let's say that x minus 3 equals 6. Okay, so what are we going to do? We want x to stand all by itself on this side of the equal sign. X minus 3 and 6 are balanced. So what are we going to do? We're going to get rid of the minus 3. And how do we get rid of the minus 3? We plus 3. If you had minus $3 in the bank, you'd add $3. So let's plus 3 to both sides. Okay, now, this is gone because minus 3 and plus 3 is 0. We have x. We're bringing my x down. X equals 9. And isn't 9 minus 3 equal to 6? Yes. Okay, let's go on. Let's see if you can do the next one. Here we have x minus 2 equals 4. Again, I want x to stand all by itself on this side of the equal sign. So what am I going to do? Well, I'm going to plus 2 on both sides. Whatever I do to one side, I have to do to the other. If I have minus 2, I'm going to plus 2. So here we go. I get rid of this, and I end up with x equals 6. And isn't that true? Yes, x equals 6. Okay. Let's find another one. Let's say that we have x plus 4 equals 8. What am I going to do? I'm going to minus 4. I'm going to minus 4 on both sides. This turns out to be 0, and I end up with x equals 4. You see what I did? X is standing all by itself on this side of the equal sign. Okay. Now, let's take a look at the next one. The next one is 2 times x equals 4. 2 times x equals 4. Now, I want x to stand all by itself on this side of the equal sign, but the glue that's holding the 2 to the x is multiplication. And I need to break this glue. And how am I going to do it? By the opposite, by dividing. So if I divided by 2 on both sides of the equation, 2 into 2 would give me 1. And I would end up with 1x equals 2 into 4 goes 2. And isn't 1x the same as x? Isn't one apple the same as an apple? Right, 1x, x equals x. So here I got it, x equals 2. Let's try that again. Let's say 3x equals 6. Again, I want my x to stand all by itself on this side of the equal sign. What do I have to do that? I have to remove the glue that's gluing together the 3 and the x, and that's multiplication. And if there's multiplication holding these together, well, then I'm going to use the opposite. I'm going to use division. I'm going to divide by 3 and divide by 3. And 3 into 3 goes once, and x will equal 3 into 6, or 2. X equals 2. Okay, we've been talking about addition, subtraction, and multiplication and division. Here we have another problem. We have 2/5 x equals 10. Now, in order to solve this problem, I need to multiply this 2/5 by its opposite. I'm going to flip it over and multiply by its opposite. And here's its opposite. And when I do this, what will happen is that everything will cancel out to be 1. I'll be left with 1x. That's on this side. On the other side, I have to multiply by its opposite here, 5/2. So I can again cancel and find out that 5 times 5 equals 25. And that means that 1x equals 25, or x equals 25. Do you see what I did? I multiplied by its opposite. Let's try another one. Let's see. Let's see if we have, let's try 2/3. 2/3 x equals 12. How do I solve this? I multiply by its opposite. And whatever I do to one side of the equation, I have to do to the other. So if I multiply by 3/2 here, I need to multiply by 3/2 here. So this cancels out, cancels out, cancels out, and I get 1x equals. And here, I can cancel and cancel, and I have 6 times 3 is 18. So 1x, or x, equals 18. So, we've started equations. What I'd like you to take a look at right now is solving equations using the substitution method. Sometimes they'll give you an equation and they'll give you a multiple choice question. And you can pick from the multiple choice responses what your answer will be. So let's take a look at this last question here. Here it says x plus 3 equals 6. And you have a choice. Either it's x equals 1, x equals 2, x equals 3, or x equals 4. And on some tests they'll say E, none of the above, or E, all of the above. Now, we can substitute. Rather than using this balance scale technique, we can work backwards and we could substitute. We could say x plus 3 equals 6. Well, if we substituted 1 for x, then 1 plus 3, does that equal 6? 1 plus 3 is 4. 4 does not equal 6. So this one would not be the answer. We could substitute again. We could say 2 will make x equals 2. 2 plus 3 equals 6. Does 2 plus 3 equal 6? Oh, no, 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 no. 2 plus 3 doesn't equal 6. 2 plus 3 is 5, and 5 is not equal to 6. So 5 doesn't equal 6, therefore x does not equal 2. Let's try the next one. Here it is, x plus 3 equals 6. 3 plus 3, we're substituting, x equals 3. 3 plus 3 equals 6, sure does. 6 equals 6. So what is my answer? Answer is C, x equals 3. I'd like you to look at Learn Math Quickly, Workbook 4. Part 1 is pages 24 to 25. Part 2 is pages 28 to 29. Remember to check your answers at the end of the chapter and come on back for Part 2. This is the second part of Video 14, Algebra. We're going to go over some more substitution problems. Take a look on the board. Here we have a more difficult equation. We have 2x, that's 2 times x, plus 4 equals 12. And that means 2 times some number plus 4 equals 12. Now, before I show you how to solve that using the balanced scale technique, you can also solve it if you have multiple choice questions by working backwards. Now, if we made believe that x was 1, then we could say 2 times 1 plus 4 equals 12. We could substitute 1 for x. So 2 times 1 is 2, and 2 plus 4 is 6, and 6 does not equal 12, so A would not be a correct response. Let's try it again. Here we have x equals 2, so we can say 2 times 2, right? Here we have x is 2. I'm going to erase this. We have 2 times 2 plus 4 equals 12. 2 times 2 is 4. 4 plus 4 is 8. Does 8 equal 12? No, it does not. So guess what? X is not 2. Let's try it again. We're going to substitute again. We're going to say 2 times x, or 2 times 3, plus 4 equals 12. Now 2 times 3 is 6, and 6 plus 4 is 10, and 10 does not equal 12. So x could not be 3. I have a feeling it's going to be the next one. Let's try it. Here we have, this is 2 times x plus 4 equals 12. And if we make x 4, then 2 times 4 plus 4, does that equal 12? Well, 2 times 4 is 8, and 8 plus 4 is 12, so 12 equals 12. None of the above is a wrong answer. The true answer is D, x equals 4. Now let's use the balanced scale technique and figure it out that way. Here we have 2x plus 4 equals 12. Now, 2x plus 4 equals 12. Now what I want to do is I want to make sure that x stands all by itself on this side of the equal sign. I want to make sure I get x equals some number. So what I'm going to do is I'm going to leave this alone for right now, and I'm going to get rid of my minus 4. Excuse me, I'm going to get rid of my plus 4. And how am I going to do it? By the opposite, with a minus 4. And whatever I do to one side, I have to do to the other side. So I can subtract this, I can erase this, and now I have 2x equals 8. Now, 2 times x, that's multiplication. I need to do the opposite. I need to divide. And I'm going to divide by 2 on both sides. 2 into 2 will give me 1. True? And 2 into 8 will give me 4. So x equals 4, doesn't it? And if we substitute here, we can find out 2 times 4 plus 4 equals 12. 2 times 4 is 8, and 8 plus 4 equals 12. So we solved that problem. Now let's go on to the next problem. Let's say that 2/3 x minus 4 equal 12. You ready? Here we go. I have a minus 4 and I need to get rid of it. Let's leave the x alone for right now. Let's get rid of this minus 4. And how do we do it? With the opposite, with a plus 4. And so I can plus 4 there and I plus 4 there. And what do I do next? Well, minus 4 and plus 4 just cancel themselves out. And I end up with 2/3 x equals 16. Now, what am I going to do next? I need to get rid of this 2/3 because I want x to stand all by itself on this side of the equal sign. And how am I going to do that? I'm going to multiply by its opposite. So I'm going to multiply by 3 halves. And whatever I do here, I have to do here. So here we are. This will just cancel itself out. Everything will be 1, 1, 1, 1, 1. And I will end up with 1x. And 1x certainly equals x. On the other side of the equation, I can cancel. 2 into 2 goes 1. 2 into 16 goes 8, and then 8 times 3 is 24. So what does x equal? Why, x equals 24. X equals 24. And if you wanted to go back and prove that, you could take 2/3 times x, which equals 24, and you could subtract 4, and it should equal 12, just like the original equation. Let's see. 3 into 3 is 1, into 24 is 8. This is 8 times 2 is 16, and 16 minus 4 certainly equals 12. So 12 equals 12, x equals 24. Let's try another one. Now in this next problem, we're going to talk about combining like terms. We have 3x minus 4 equals 10 plus x plus 2. And on this side of the equal sign, there really isn't anything that we can combine. But looking on this side of the equal sign there is, what would you put together? I'd put together the 10 and the 2. So let's say 3x minus 4 equals 10 and 2 is 12 plus x. What can I do next? I have a few things I could do. I could bring my minus 4 over this way, or I could bring my x over this way. And I've decided that I'd like to bring the minus 4 over that way. And how am I going to do it? Why, I'm going to plus 4. And whatever I do to one side of the equation, I have to do to the other. So if I plus 4 here, I have to plus 4 here. So this cancels itself out, and I am left with 3x equals 16 plus x, right? 12 plus 4 is 16. And now I need to get rid of my x. The x's should go on this side and the numbers on this side. Let's bring it over. If I have a plus x, I'm going to minus x. So here we have a minus x. I can I can erase that, and now I have 3x minus x. So I have 3x, and I'm going to take away an x, and I'm left with 2x. And 2x is going to equal 16. I still need to make x stand all by itself on this side of the equal sign. I'm looking for what x equals, not what 2x equals. So what am I going to do? The glue that holds these together is multiplication. I'm going to do the opposite. I'm going to divide by 2. 2 into 2 goes once. 2 into 16 goes 8 times. So x equals 8. Now let's see if I got the right answer. We can go back to the original and we can substitute. We can say 3 times 8 minus 4 should equal 10 plus 8 plus 2. Is that true? This is 24 minus 4. Does it equal 18, 19, 20? Does it equal 20? Well, yes, it does. 24 minus 4, 20 equals 20. That was a very long and complicated equation. Let's try one more and see how you do. In this equation, we have a parentheses. Here we have 2 times x plus 2 equals 22 minus 4. Now, I want to get rid of this parentheses. And the way I'm going to get rid of the parentheses is I'm going to multiply 2 times x, and then I'm going to multiply 2 times 2. So 2 times x is 2x. 2 times 2 is 4. Now 22 minus 4 is what? 22 minus 4 is 18. Now what can I do next? Well, I could get rid of this. I could do minus 4 on both sides. That will cancel this out. And then I will end up with 14 here. And I will have 2x equals 14. And now I need to get rid of the 2. And the glue that holds this together is multiplication. So let's divide. This will cancel out, and I will find out that x equals 7. Is that true? Let's substitute. Let's say 2 times 7 plus 2 equals 22 minus 4, which is 18. Now 2 times 7 and 2 is 9. 2 times 9 equals 18. So there it is. Please go to the Learn Math Quickly Workbook 4. Do Part 1, pages 26 to 27, and Part 2, pages 30 to 31. And then please take the Algebra Test 1 on page 32 and the Algebra Test 2 on page 33. They're cumulative. And then check your answers at the end of the chapter. And I'll see you for Algebra 3, video 15.